In this video, we're going to look at sum and difference of cubes and review all types of factoring. So my first two examples, I've got GCF. GCF stands for greatest common factor. So let's take a look at two examples of picking out a greatest common factor. So 6n cubed minus 3n to the fifth. So both of these numbers would divide evenly by 3. So we want to take out the 3 and write it in the front. And then you think of how many n's could I take out? So this first term has 3 and the second term has 5. So I could take out 3 of them and that would be okay since they both have at least 3 n's. Then what would be left over is 6 divided by 3, which is 2. But then I took out all of those n's, so nothing else is left for that first term. And then 3 divided by 3, nothing else is left for my number, but I have 2 n's left over. Because I took out 3, there will be 2 left over. So you always want to take out the greatest common factor and then try to write what would be left over in parentheses. Let's look at number 2. So we have negative 8 x to the 7th plus 24x to the 6th plus 12x to the 5th. So if this first term is negative, you want to take out a negative. And then you might think these divide by 8. But then 12 would not evenly divide by 8, so that number is too large. But we could divide all of them by 4. So let's take out negative 4. And then you look at x has 7 in the first term, we have 6 in the second term, and 5 in the third term. So we could take out 5 because that's how much the smallest number was. And then think of what would be left over. So negative 8 divided by 4 would be 2. I took out 5 x's, so there are 2 left over. In the next term, 24 divided by 4 is 6. I took out 5 x's, so I have 1 left over. And then in the third term, I have 12 divided by 4, which is 3. And I took out all 5 x's, so none were left over. Okay, so those are just two simple examples of greatest common factor. For difference of two squares, it follows a pattern. So the pattern is if I have a squared minus b squared, so two perfect squares that are being subtracted, then I say that factors into two binomial factors. One would be a plus b, and one would be a minus b. So you want to take the square root of each term and put it into a binomial. One would be added and one is subtracted. So for x squared minus 36, you'd want to take the square root of those and say, well, the square root of x squared is x, and the square root of 36 is 6. And you want to write x plus 6 and x minus 6 are my factors. Okay, another example is 4x squared minus 9. So if you think of the square root of each one, you get 2x and 3. So your factors would be 2x plus 3 and 2x minus 3. It just follows a simple pattern. So you don't have to think of lots of steps. You just have to remember the pattern for difference of two squares. Okay. So sum and difference of cubes is also a pattern. So if I have a cubed plus or minus b cubed. So let's write both of them down over here. So if I have a cubed plus b cubed, so that's the sum of two cubes, it would factor into a binomial and a trinomial factor. And my signs are going to be plus, minus, plus. And then we'll talk about the terms in just a minute. If I have a cubed minus b cubed, so the difference of cubes, because you can factor either one. For squares, you can only factor the difference of two squares. But for cubes, you can factor sum or difference of cubes. My signs, it's going to be a binomial and a trinomial factor still. And my signs will be minus, plus, plus. So another way to remember that is this first sign is the same as the one that you started with over here. And then the next one is opposite of that. And the last one is always positive. I can't spell, so let me put that back. Always positive. And what that spells is the word soap. So you can remember SOAP. Same, opposite, always positive, or you can just remember the pattern. Plus, minus, plus, and minus, plus, plus. So in your binomial factors, you would put the cube root of a cubed and b cubed. So the cube root of something cubed is just equal to itself. So that first term would just be a. Same for b, so the cube root of b cubed is just going to be b. So your binomial is going to be the cube root of your two original terms. The next set of terms, the trinomial factor, comes from your binomial. So in the first term of the trinomial, you're going to square the first term in the binomial. So it'll be a squared. Same in both. For the last term, you're going to square it. So b squared goes at the end, and b squared goes at the end. And in the middle, you're going to multiply those two together. So that will be a times b. And again, it follows the same pattern for sum or difference of cubes. All right, so let's put this into our examples. So we have number 1 is 8x cubed minus 27. So what I'm going to do is set up a binomial and a trinomial factor. I noticed that those are all perfect cubes. 8, x cubed, and 27 are all perfect cubes. So we can take the cube root of 8x cubed, and we get 2x. And the cube root of 27 is 3. Let me write that down. And we put the same sign in our binomial. So 2x minus 3 is our binomial. I've got minus, I'm going to have plus, plus, or same, opposite, always positive. Now for the first term in my trinomial, I need to square the first term in the binomial. So 2x squared is 4x squared. Then for the last term, I need to square it. So 3 squared is 9. And you've already got your signs in place, so you don't have to worry about those. And then you want to multiply these two together. So 2x times 3 is 6x. Again, you've already got your signs in place. They follow a pattern, so you don't have to think about the signs. Just think about the pattern. Okay, let's do another one. So x cubed plus 125. I notice that's a perfect cube because the cube root of x cubed is just x. And the cube root of 125 is just 5. So I set up a binomial and a trinomial. I know my signs are plus, minus, plus, or same, opposite, always positive. All right, so then we're going to fill in the cube root of those first two terms. Square the first one to get the first one in the trinomial. Square the last to get the last. And then multiply them together and put them in the middle. And that's it. So once you get used to the pattern, it's really not too terrible. But let's look at another one. We've got 16x to the 4th plus 2x. So this one is not a perfect cube, but we could take out a greatest common factor first. So let's take out 2x, and we would get 8x cubed plus 1 left over. And what's left over is a sum of two cubes. So we've got to continue and factor it into a binomial and a trinomial. We need plus, minus, plus. Same, opposite, always positive. All right, so the cube root of 8x cubed is 2x, and the cube root of 1 is 1. So let's put those in our binomial. All right, so square the first one to get the first one. Square the last one to get the last one. And multiply those together and put them in the middle. And that's it. I think we have one more example of that type. So 2x cubed minus 54 is not a difference of cubes just yet, but we can take out the 2 and we'd have x cubed minus 27 left over. And those are perfect cubes because the cube root of x cubed is x and the cube root of 27 is 3. So let's set up the 2 stays on the outside, and we have a binomial and a trinomial factor. We have minus, plus, plus for our signs. And let's see, x and 3 go in the binomial. Then square the first to get the first. Square the last to get the last. And multiply them together and put that in the middle. Okay. So let's see. For this video, I'm going to start a new video to go over the last 3 types of factoring. So you can have a break.